Hello, TTI family. Today, we're getting a sneak peek into the future. And honestly, it looks like something straight out of a sci-fi movie. Except this time, it's real. In this project, a seriously talented creator sets out to design and build an actual flying car. Yep, not a concept, not a sketch. A real, lift-off-the-ground flying machine. This isn't just a casual weekend DIY. It's a full-blown engineering adventure that blends the worlds of cars and aircraft into one ambitious build. And as you'll see, pulling this off takes careful planning, smart material choices, and a whole lot of patience. Plus, probably a few "why did I start this" moments. The journey kicks off with building a helicopter-style system that will eventually sit on top of the car. Because, apparently, regular roofs are just too boring. To support all of this, the creator starts with a strong, yet lightweight frame. Aluminium is the material of choice here, thanks to its impressive strength without the extra weight, and its resistance to rust. The process begins by cutting and assembling aluminum beams, which are then reinforced using custom-made brackets. To make things even sturdier without turning the build into a flying brick, carbon fiber plates are added. These bring rigidity while keeping everything nice and light, basically the superhero of materials. Next comes the heart of the machine, the propulsion system. Inspired by quadcopters, multiple electric rotors are installed to generate vertical lift. During testing, the system goes through a series of checks to make sure everything runs smoothly and, most importantly, doesn't decide to fly off without the rest of the car. With the lifting power sorted, attention shifts to the body. The outer design needs to be sleek enough to cut through the air, while still being strong enough to handle both flying and driving. The surface is carefully prepared, smoothed out, and shaped using a custom mold that defines the vehicle's aerodynamic form. Fiberglass layers are then applied and bonded with resin, creating a solid shell. Reinforcements are added where needed, and the entire structure is cured until it becomes tough yet slightly flexible, ready to handle the forces of flight. Now comes the part where things get extra fancy, and slightly intimidating if you've ever struggled to wrap a gift neatly. The carbon fiber sheets are carefully laid out to match the exact curves of the design. And this isn't just arts and crafts. Each fiber has to line up perfectly, so the strongest areas handle the most stress. After precise trimming and sanding, the body is refined to ensure smooth airflow. A glossy finish is applied, not just for looks, but to reduce drag and improve efficiency. Finally, advanced carbon fiber components are introduced to further enhance strength while keeping weight low, bringing the flying car one step closer to reality. Basically, it's like giving the flying car a perfectly tailored suit. except this one can handle takeoff. Once everything is in place, resin enters the chat. This sticky superhero binds all the layers together, turning flexible sheets into a solid, durable structure. But there's a catch. Too much resin, and you're adding unnecessary weight. Too little, and you risk weak spots. So yeah, no pressure. Just the difference between flying machine and expensive lawn ornament. To make sure everything bonds flawlessly, vacuum bagging is used. The entire setup is sealed under a plastic sheet, and the air is sucked out to create even pressure across the surface. It's kind of like vacuum packing food, except instead of preserving leftovers, you're building something that might actually leave the ground. The result? No air bubbles, no gaps, just a smooth, strong, and lightweight component. Once cured, the carbon fiber hardens into its final form, and it's time for cleanup. Excess material is trimmed, edges are refined, and every surface is smoothed out to keep airflow nice and steady. Because when you're dealing with high speeds, even small imperfections can turn into big problems. Think of it as giving the car a haircut, but one that improves aerodynamics. The payoff here is huge. Carbon fiber doesn't just make the structure lighter, it also makes it incredibly strong. That means the vehicle can handle the intense forces of takeoff and flight without falling apart mid-air, which, let's be honest, is a pretty important feature. With these upgrades, the project starts looking less like a wild experiment and more like an actual flying prototype. It's a perfect blend of advanced materials and smart engineering, slowly closing the gap between cars and aircraft. Next step? Mounting these carbon fiber components onto key parts of the frame so everything works together as one solid system. At the same time, custom parts are being created using 3D printing. These pieces are designed for specific roles, like brackets, housings, and aerodynamic tweaks, and they fit right into place without any fuss. It's fast, precise, and honestly, a bit futuristic. Then, the frame comes together piece by piece. An internal aluminum structure reinforces the chassis, acting like a protective cage while supporting all the mechanical components. At this point, the build is no longer just ambitious. It's starting to look seriously ready to fly. And now for the moment we've all been waiting for. The part where this thing actually tries to become a flying car. The propulsion system is mounted on top of the frame, and all the electrical and control systems are wired together. In other words, this is where everything goes from cool parts collection to, okay, this might actually lift off. With the structure and rotors in place, the builder runs a series of initial tests to check performance, stability, and, most importantly, that nothing decides to fly off before the car does. Once those checks pass, it's time for the full assembly and the ultimate test: flight. Yep, after months of work, it finally gets its chance to leave the ground and prove it's more than just a really ambitious garage project. What makes this build so impressive is how it combines modern materials with drone technology, turning a compact car into something that can both drive and fly. It's like giving your daily commute a skip traffic button. Of course, there are still hurdles. Rules, infrastructure, and tech upgrades all need to catch up. But this project clearly shows what's possible. It's not just a wild idea anymore, it's a working glimpse into the future. Because let's be honest, the moment cars start flying, traffic jams are going to feel very outdated.